Hello everyone, my name is Dumitru Login and I'm a senior software engineer at OKX. And today I will introduce X1 to you. After the introduction, I'm going to present more details about the technology behind X1, some of the developer tools that you can use, and at the end, I am going to show you some useful context. What is X1? X1 is a zero-knowledge proof-based layer 2 network, which is built by OKX using Polygon Chain Development Kit, or CDK for short. It's a layer 2 network, so it inherits the security of the underlying layer 1, which is Ethereum. It provides EVM equivalence. This means that your smart contracts that you develop for Ethereum layer 1, they are also being able to be ported to X1. And you can also use your favorite development tools, for example, Remix, IDE, Truffle, Hardhat, Web3.js to develop applications on X1. What sets it apart is that it uses OKB as a native token on layer 2 to pay for the gas fees. And also it has quite high performance. For example, more than 100 transactions per second at the sequencer side and more than 10,000 queries per second at the RPC side. And I'm going to introduce these components later. So being built by OKX, it has seamless interoperability with the OKX ecosystem, including the OKX wallet, OKX DEX, OKLink, and so on. It has very low gas fees, and this is because X1 is using the Validium mode with data availability nodes to store the bulk of the transaction data off-chain. And I'm going to tell you more about this mode later. X1 also provides a free bridge system. This is to allow users to bridge their assets on L1 to L2 at no cost and also automatically. So X1 is built using Polygon CDK, and as you can see on this slide, Polygon CDK has some advantages compared to the competition. In particular, it supports Validium mode, and it has state-of-the-art zero-knowledge proof technology. So what is the Validium mode? And here I'm going to compare it with the widely known rollup mode. So in the rollup mode, on layer 2, we have transactions and we generate zero-knowledge proofs for these transactions. And we put both the bulk of the data of these transactions and the zero-knowledge proofs on layer 1, in this case, Ethereum. But uploading this data to layer 1 requires significant gas, so it ends up being very costly. Another model is the Validium, where we don't upload the bulk of the transaction data to L1. Instead, we store it off-chain on data availability nodes that are governed by a data availability committee. And we only put the zero-knowledge proof and the headers of the transactions together with the signatures of the data availability nodes to layer 1. This will reduce significantly the gas cost and makes the Validium mode more scalable and more affordable. Let me show you some details about the technology behind X1. X1 is using modular architecture that is highly scalable and can be implemented using microservices. For example, we have a JSON RPC service that interacts with users. We'll take the user's RPC and save them to the database, for example. Then we have a sequencer that produces blocks of transactions and batches of blocks. Once we have blocks of transactions, the ZK EVM executor executes them and updates the state database. And as you can see here, this database service is a core component of the layer 2. It's connected to many of the other services. It provides, for example, the transaction pool database, state database, events database, and so on. We have the synchronizer that listens for events on layer 1 and uploads them on the database service. And the bridging of assets from layer 1 to layer 2 that I talked previously is done using this synchronizer service. This will allow us to have automatic bridging of assets from L1 to L2. Next, once we have batches of transactions, the sequencer will push them to data availability nodes and also tell the aggregator to start creating zero-knowledge proofs for the batches. The aggregator will create tasks for the prover, and the prover will be the component that actually computes the zero-knowledge proofs for the batches of transactions. Once we have these proofs, we upload them on L1 using the ZK AVM contract. In addition to this contract, on layer 1, we have the bridge contract and the OKB contract. So in regards of the zero-knowledge proof technology behind X1, we use the state-of-the-art Polygon ZK prover. And this component takes batches of transactions and generates the zero-knowledge proof for them. But first, it executes these transactions using an executor that consists of a main state machine executor and a collection of secondary state machines for other components such as the stack and different hashing mechanisms. We have then the proofs that are Stark proofs, and then we combine them recursively into a lower number of proofs until we end up with a single Stark proof, and then we take this proof and transform it into a snark proof and put this snark proof on layer 1. And why we do that is because snark proofs are smaller in size and also easier to verify on L1, and this will further save gas. This diagram shows you more details about the process that I already mentioned. So we have batches of transactions, we generate Stark proofs, we combine them into recursive proofs, and in the final stage, we end up with a single Stark proof. We transform this into a snark proof and upload this snark proof on Ethereum layer 1. Next, let me show you some of the developer tools that you can use to start developing applications on X1. You can use OKX wallet. This is a non-custodial wallet that will provide you, among others, asset auto-detection, multiple chain support, including popular EVM chains, non-EVM chains, also layer 2 chains. It's Web3 native, fully interoperable with the apps, and also it supports hardware connectivity. This means that you can connect your hardware wallets. We also provide support for OKLink, which is a world-class multi-chain blockchain explorer. And this will allow you to search for useful data such as addresses, tokens, prices, and transactions. And for example, you can connect your D app to OKLink using the API. You can do on-chain analysis and also audit your smart contracts in order to ensure that they are secure enough. We provide an oracle, X1 oracle. This will provide developers pricing data and also verifiable randomness functions. And of course, we also provide Faucet. This is to help developers test their applications, right? When they test their application, they need some tokens on the testnets. We provide an X1 Sepolia Faucet. And you can generate, for example, test OKB tokens in order to test your application. And I'm going to show you how to do that later. To stay up to date with all the news regarding X1, you can join our builder community by scanning this QR code. Next, let me show you the documentation of X1. For this, you can use your browser and go to this address, okx.com/x1. You should be able to see this page. Then click Start Building. And here you have some useful documentation. For example, what is X1, build on X1, deploy smart contracts. And this is of interest to us. But first we need to set up our wallet. So under user guide, you can go to setup wallet. And for example, we support the OKX wallet, MetaMask, Particle Network. Of course, we highly recommend using the OKX wallet, which is a very powerful Web3 native non-custodial wallet. And I'm going to show you later how to install and use the OKX wallet. And in OKX wallet, you already have the X1 testnet configured. You just have to select it. On other wallets, you may need to configure the network information manually, and you can find it here, right? For example, network name is X1 testnet, RPC, URL, chain ID, token symbol is OKB, as we mentioned before, and block explorer. Okay, and you can see here more details, including how to set up MetaMask, right? So we have network information, the one that I already mentioned to you. Okay, currently we have the testnet online. X1 mainnet will come online later. Faucet, right? We can get testnet OKB from the faucet. And also we can bridge testnet OKB from Sepolia testnet. This is on layer 1 to X1, which is layer 2. And we also have here on how to bridge assets from Sepolia to X1 testnet, step by step, right? And below we have other links to GitHub, X, Discord, and so on. Now let me show you how to install the OKX wallet in Google Chrome. For this, we go to extension, manage extensions, and we go to Chrome Web Store and look for OKX wallet. Okay, OKX wallet. Then we click add to Chrome. Okay, and now it's added to Chrome and we can pin it here. Now let's open the wallet. We click here, and of course we need to create a wallet. With seed phrase, we will set up a password. Make sure you set up a strong password. We can set it as default also, and then we are able to start our Web3 journey. Of course, it's recommended to back it up. I'm not going to show this step. You can do it by yourself later. And we can select the X1 testnet. If we go to testnet, we can already see X1 testnet and OKB as a native token. So now we have our wallet installed, OKX, let's spin it. But before deploying smart contracts, we need to get some OKB tokens. So we can go to X1 website, start building, and we go to faucet to get some testnet OKB. And we have the documentation here. Let's click the link. We can connect our wallet by clicking here, connect wallet. We approve it in the wallet. Okay, now it's connected. So we can get some OKB. And indeed, this is our address. We can check right in our wallet. And let's switch to the X1 testnet. Okay, so that we can see our OKB tokens later. We press get. We need to complete this puzzle. Okay. And we should already have 0.2 OKB. We don't bridge it for now. And indeed, we see in our wallet, we have 0.2 OKB. So now we can start to write a smart contract and deploy it. Let's use the Remix IDE. This would be like a remix. We can search on Google, for example. It's remix.ethereum.org. Let's create a new workspace with widely used ERC20 smart contract template. ERC20 is for fungible tokens. Let's make it mintable. And we have the code here. We can go to the source code, mytoken.sol. It's in Solidity, of course. Let's change the name. Let's call it my awesome token. And here, MAT. Okay. And now by default, it has a denomination which is 10 to the power of minus 18. So when we mint, right, we want to see some meaningful value. Okay, so let's multiply the amount here by 10 to the power of 18. Okay. We can save and we can also compile our code. It compiles successfully. And now we go to the deploy and run tab. So here is where we need to connect Remix IDE with our wallet and then on X1 testnet. So let's connect it to the wallet first. Connect to wallet, and it should already detect that we have the OKX wallet installed. And we approve this connection, and we can see here our address, right? Even under this tab, under account, we can see our wallet address here. Now we are still on the mainnet, so we need to go to the wallet and change this. So for example, under the connections, remix ethereum.org, manage, and we should change here the network to X1 testnet. For this, we can search X1. We found it. Okay, so now it's connected to our X1 testnet, and indeed we can see here that we have a custom network, and this is the ID of X1 testnet 195. So now we have our token contract. Let's deploy it using our address. So let's copy our address under initial owner, transact, and this should open the wallet, right? Indeed, because we need to pay the gas fee. We confirm. And it's already deployed. We can see it below here under deployed contracts. My token was deployed at this address, 0x86D and so on. Okay, now let's mint some tokens. But in order to see them in our wallet, we have to import this token. So we go to we go to our wallet, right? And then under manage crypto, custom crypto, we should introduce the address of our smart contract. And indeed, the wallet will automatically take the symbol and decimal points. We confirm. Okay. Then go back to our main screen. For now, we only have 0 of my awesome tokens. So let's mint some. For this, we copy again our address and we go below under mint, okay, to our address. And let's say we mint 15 tokens. Transact this again. We're required us to pay the gas fee, confirm. And we should already have them. Let's check. Indeed, we already have 15 MAT, my awesome token. Of course, we can also interact, for example, owner. This one should return our address. Okay, let's check again. Indeed, it returns our address. Now let me show you how to use WebSockets. And again, we should go to X1 documentation under developers, build on X1, WebSocket endpoints. Okay, you can read here and we can try it out by installing this WS tool with Go and then connect it to X1 WebSocket endpoint and subscribe, for example, to events such as new heads. Right? This one will give us new headers. So let's try it out. We first install this tool. Okay. We should have it already, indeed. Now we connect to X1 endpoint. Okay, and now we subscribe to new headers. This is successful. Now we should generate some activity to get headers. So, for example, we can go to the faucet and get some OKB. And we get some activity here. Now let me show you how to use the bridge to bridge assets from L1 to L2. We go to the documentation, getting started, bridge, and we can read here more about this bridge and how we can bridge assets. So let's go to the bridge web page. And for this, we can connect our wallet, the OKX wallet. Okay. And we are going to bridge OKB tokens from Sepolia testnet, which is on L1, to X1 testnet, which is layer 2. But before that, we need to have some OKB on Sepolia testnet, which is L1. So for this, let's go back to our X1 web page. Use faucet to get some OKB tokens on Sepolia. Okay, we click here and we can get a maximum of 10. Okay, let's mint. One thing to mention here is that in order to use this faucet, you need to have some Sepolia ETH in your wallet, right? And you can get this using third-party faucets such as the Alchemy faucet. It's quite easy to use. You just need to create an account, log into the account, and then mint some Sepolia ETH. Okay. Now we minted 10 OKB on L1. Okay, we add the token to our wallet. Then we should be able to see it in our wallet, and indeed we have it here. We have 10 OKB on L1. And now let's bridge. Okay. We have to select here OKB, and the web page will automatically detect that we have 10 of them in our wallet. Okay, let's say we only want to migrate 5. Then we press bridge. Okay. And we need to confirm this. And of course, we need to pay the gas fee on L1, but only on L1. On L2, we don't need to pay the gas fee. It's automatically paid by our platform. And we need to wait a bit. Estimated waiting time is 15 minutes. Now the transaction is done. We can see it here. Now let me show you how to use X1 Oracle. For this, we go to the X1 documentation, go to developers, and we have Oracle here with price feed. Currently on the testnet, we provide price feed API, and we have some examples here. We have a code example, and I'm going to show you that this one is working. So for this, we go to our Remix IDE, the same contract as before, my awesome token. We'll just add this functionality and try to get the price of the OKB token. Okay, so for this, we import this interface. We add it to our smart contract here. Okay. After that, we also need these two functions. I'm just going to copy them and add them to our smart contract here. And we finally need the Oracle address. So for this, I'm just going to copy it from here. Okay, and add it here. We have an error here. Let's fix it. We should have the address properly formatted. Okay, now the code compiles. We just have one warning, but this is not so important. The one thing we need to change is that we want the OKB price. So here we'll input OKB token symbol. Okay. So the code compiled. Now let's deploy it. But for this, we need to connect our wallet. So we go wallet connect the OKX wallet. And we are indeed on X1 testnet. 195 is the ID of this testnet. Okay, and we want to deploy my token. We will use our address and deploy it. For this, of course, the wallet should be shown in order to confirm the transaction. We confirm it. And we already have the deployed contract here. Now, when we expand this, we can already see that we have this method called getOKBPrice. Let's try it out. And we already have some response here. If we expand it, we get the value, which is 560165571. It's actually $56